at any point is 0. Okay. And Kirchhoff's voltage law states that the algebraic sum of the EMFs and the voltage drops in a closed loop is 0. This I have already explained to you in the theory class. Summation of the EMF plus summation of IR. IR is the drop. This is the EMF, voltage drop. This is equal to 0. So the different apparatus you will be using here is voltmeter. So here Kirchhoff's voltage law and Kirchhoff's current law, both you will verify with DC supply. You will provide DC supply and you will verify it. Okay. And AC supply is also applicable in AC circuit. You can also apply Kirchhoff's voltage law and Kirchhoff's current law. Who has joined now? Suyash. Suyash, are you there?
Yes, ma'am.
Who is doing? Outside KIT University, Suyash, who is doing this one? Huh? You think to be very smart or what? Whoever is there, whoever is doing this one, you think to be very smart. The class will enter and thinking to be very smart. You are the fullest. Who is doing out of all this 91 student, whoever is doing, I am telling to him only. You are the fullest person. Okay. You do. How many times you are entering, there is no issues. Enter. Once again enter. 100 times you enter. Nothing will happen. You will think to be very smart and you will escape like this. You will definitely be cut. Mind it. Don't be so over smart. I am not telling to all of you. I am telling to who is doing. Only to that person. Okay. I am not telling to you. So those who are not involved in this, I am not telling you at all. Whoever is involved, I am telling to only that person. You think to be very smart. If you have gods, you enter 100 times. Let us see. Okay. So here, what you will do, you will use this voltmeter, which will measure the DC voltage, ammeter, which will measure the DC current, having the range 0 to 1 to 2 ampere. Okay. That means the lower range is 0 to 1, upper range is 0 to 2. Tungsten filament lamp you are using. We will be using offline and online, both the experiment you will be doing, then rheostat, then connecting wires. Now look at here. I will quickly move because 2 experiments you will be doing. So here you see 220 volt DC supply you are giving. Okay. Well, these are the protective device. This is a potential divider. Potential divider means you are providing your 220 volt DC supply. What you will do it is, you will vary the DC voltage. You can vary the DC voltage with the help of the potential divider. Okay. So potential divider connection you will see in the video, the offline video which will be shown to you. Here you can change this moving point. You will change this moving point such that what will happen? Here the resistance between these two terminals will change. Okay, so when this resistance will change, the voltage will also change between these two terminals. So you have connected a voltmeter. This is a DC voltmeter. You see under V a straight line is there. This is a DC voltmeter which will measure the DC voltage. This is a DC ammeter which will measure the DC current. Okay, and these are the lamps. These are the tungsten filament lamp we are using, or these are the loads, or you can replace it by the help of resistors. Simply because these are all resistive element, only resistor. Tungsten filament lamp which you are using, they are only purely resistive load. So whatever, this is a single node, these 2 points are sorted, this is a single node. So how much current is flowing to this particular node, how much current is flowing out from this, how much current is flowing out from this, you will see. How much current is entering, how much current is flowing out. So you just check what is whether Kirchhoff's current law is valid or not. Okay. Any doubt with this one?
Ma'am.
Tell.
मैम वो जो लास्ट पार्ट थोड़ा फिर से बोल देंगे क्या, जो नोड के बाद से?
यहाँ पर how much current is flowing here, how much current is entering into this node, you will see how much current is going out, you will see with the help of this ammeter. With the help of the ammeter, you see how much current is entering to the node, how much current is going out of the node, because loads are there. Current will flow in this path, current will flow in this path. You check what is the current flowing in this two ammeter, you check what is the current flowing in this ammeter. So this current will be equal to sum of these two current. Am I clear now?
Yes ma'am, yes ma'am, yes.
Okay, so this is a simple circuit I am giving you. I will ask you to do some little, I will give you some circuit. You will also verify with those circuits. Okay, not this simple circuit is not enough. You will verify some other circuits I will be giving you. Okay, you will solve it by using theoretically whatever you have read, the Kirchhoff's current law, Kirchhoff's voltage law. You will find out the Kirchhoff's with the help of Kirchhoff's voltage law, find out the voltage. Just using the components in the simulator, you will check what is the voltage. Okay, you so that your Kirchhoff's voltage law will be verified. Okay. Now
Yes,
come to Now come to here. This is here also 220 volt DC supply is given. Okay, this is the protective device. Same with the help of potential divider, you are changing the voltage. So with the help of this voltmeter, you are measuring the voltage. Okay, you have connected three tungsten filament lamp. Tungsten filament lamp, which why we are using, because these are all purely resistors. Okay, yes, somebody is asking something. Anyone is asking? No. Okay, no, so these are all the resistors. Tungsten filament lamp is a purely resistive load. Okay, so that is the reason why you are not using nowadays, because it will only consume the power. Power will be dissipated in that lamp. Okay, because that is the only resistor. Wherever there is a resistor, remember that there will always be a loss in the power. Okay, there will always be the loss in the power in the form of heat. Okay. So here what we are doing, we have connected a voltmeter across this tungsten filament lamp. Here also we have connected, here also we have connected. 3 voltmeter we have connected. How much voltage we are providing, you will measure these 3 voltage and you check how much voltage we are providing. This voltage will be equal to this voltage plus this voltage plus this voltage. This is how you will verify it. Am I clear now?
Yes, ma'am.
Yes, ma'am.
Ma'am, what is that ICDP on that in that circuit diagram?
Who asked this question?
Ma'am, Supratim.
And tell me your name. Who?
Supratim Bhattacharya.
Supratim. Very good. Very good. I was supposed to ask you this question, but you asked. Very good. I am happy. When you are asking these types of questions, I am very happy that you are involved. So ICDP is ironclad double pole. Okay, ICDP is ironclad double pole. You will see in the video this ironclad double pole. Okay, ironclad double pole, maybe they are not using. I will show you the image. Okay, here what happens, what we are doing it is, we are giving 220 volt DC supply. How will you provide it? How will you provide it? We will use the ironclad double pole so that in a single throw this will be connected. 220 voltage supply will be connected to the circuit. Understood? Got it?
Yes,
here you see, yes, I will ask now, you see here, this one is a dotted line actually. What is the function? Why dotted line means what? Tell me. Yes, tell me. Dotted line means what? Here you see, you are able to see the dotted line?
Yes, ma'am.
Yes, ma'am.
What is the, why the dotted line is there? Then why you have not asked you the question? Each and every component you should know. Each and every component you should know. Each and every. Wherever you are having any doubt, okay, we are not expecting that you know everything. Actually, this is dotted line means this is mechanically connected. You cannot connect it electrically. Plus, minus, you cannot sort it. Okay. You will connect it in mechanically. Clear? Nowadays, actually, we are using this protective device. We are in place of this all this protective device, we are using MCB. With the help of MCB, we are connecting now 220 volt DC supply to the circuit. Am I clear now?
Ma'am,
Yes.
Tell.
can you again tell what is the role of ICDP?
ICDP is, let me see, I don't have actually ICDP. ICDP ର image ଅଛି ବନ୍ଦନା ମ୍ୟାଡାମ ଅଛି କି? ବନ୍ଦନା ମ୍ୟାଡାମ ICDP
मैडम
आयरन क्लास डबल पोल ଅଛି କି ଭିଡିଓରେ ଦେଖି ହେବ ପିଲାଙ୍କୁ
ना
ଲ୍ୟାବରେ?
मैडम ना मैडम
Here you see, I am showing you iron clad double pole. Here you see this one.
Yes, ma'am. Understood.
Yes,
ma'am. Understood, ma'am. Yes, ma'am.
Understood?
Yes,
मैम
ma'am.
ये फ्यूज जैसा दिख रहा है.
हाँ,
Ma'am, yes,
हाँ
ma'am.
वो
Fuse
घर
box
में
है.
रहता फ्यूज बॉक्स में रहता
ये डबल पोल मतलब इस देखो यहाँ पर सिंगल थ्रो में ही वो 220 वोल्ट डीसी सप्लाई कनेक्टेड होगा, समझ में?
Yes, ma'am.
ये mechanically connected. You will not connect. Where is my diagram? Let me show you. Here you see, here these two will be mechanically connected. Understood? In a single throw, I have shown you na, that throw. When you will switch on this one, that means it will be mechanically connected. 220 voltage will be given to the circuit. Understood?
Yes, ma'am.
Yes, ma'am.
यस मैम
Yes. So that is ironclad double. Actually, nowadays we are using MCB. Okay, instead of
Yes, ma'am.
this
Before-
fuse and DM, we are using miniature circuit breaker. All of you have seen
Yes.
miniature circuit breaker? I
Yes,
have
ma'am.
Yes.
shown you.
Yes, ma'am.
Yes. So this is your video. Next, I will give you one or two problem. You see the video first, Kirchhoff's current law and Kirchhoff's voltage law. Both the video you see. Then I will you will verify in this circuit. Another two circuit for KCL, another two circuit for KVL. I will give you. You will solve it theoretically and you will also verify it in this lab only. Or your after that only your lab will be complete. Okay, madam, you now said, tell.
Ma'am, can you please scroll downwards, ma'am, to the observation table?
Yes, observation. Yes.
Yes, ma'am.
Observation table. Yes, observation table.
In the manual you shared with us, that in that manual the observation table is all मतलब text ऊपर आ गया है.
अच्छा, मैं PDF भेज दूंगी.
हाँ,
I
हाँ.
will show you the video. Okay. I will send you the video. Just after this class, I will send. See, what you will do it in the observation table for Kirchhoff's current law. Whatever the voltage you give it, with the help of the potential divider, you change it, change the variable point, give some voltage, connect, you see the ammeter current, okay? Then the other two ammeter will measure I1 and I2. You will see that I1 is equal to I1 plus I2. Here I want to tell you, when you are doing the experiment practically, you may not be getting exactly equal. Okay, I will not be exactly equal to I1 plus I2. There may be a loss, some loss will be there. Okay, because conductors you are using, they are not pure conductors. So practically you will be having some loss. I may not be equal to I1 plus I2. But it's not that there will be a large variation. Plus minus 10% is acceptable. Okay. So in the remark, you will write I is nearly equal to I1 plus I2. If you are actually not getting the value, you will not write I is equal to I1 plus I2. I is nearly equal to I1 plus I2. Similarly, here you give some voltage, measure the voltage V1, V2, V3. Okay. Then you will see that V is equal to V1 plus V2 plus V3. Here also some loss will be there. Okay. So V will be nearly equal to V1 plus V2 plus V3. This is what exactly you will be doing. Calculation is not required. And here do these two circuit which I have given you. These are all very easy circuit. You will do some another 2-3 circuits, 4 circuit I will give. 2 circuit for KCL, 2 circuit for KVL. You will solve it theoretically using Kirchhoff's current law and you will check it practically with the help of
Ma'am,
simulation.
so total how many circuits we have to do? Ma'am,
Total
you are
3
giving.
circuits. Total
Huh?
3 circuits. I will
Okay.
tell you. You let
Okay.
me you see the video. Yes, madam, you start the video. Any other doubt? Anyone having any other doubt? Tell me.
Excuse me, ma'am.
Tell.
Yes, ma'am. In the first circuit of KCL, ICDP is not mentioned. Why so? It
I
is
have
not.
told you. I have told you. Actually, now what we are doing it is, these are all protective device. ICDP has been shown, but here you see when you do the experiment, instead of using all this directly, we are connecting the DC supply to the circuit with the help of MCB actually. Okay.
Okay. Yes, ma'am.
Directly we are using MCP. Actually, this total circuit we are using at an MCP. Understood? This is replaced with the MCB, miniature circuit breaker. Okay. In the video also you will see miniature circuit breaker. The circuit will be connected. Understood?
मैम आप जो बोली आईसीडीपी जो वो मैकेनिकली कनेक्ट होता है मैम मैकेनिकली कनेक्ट का मतलब क्या होता है मैम
मैकेनिकली कनेक्टेड मतलब देखो तुमको मैं जो पिक्चर कहाँ गया मेरा पिक्चर देखो जो पिक्चर में दिखा रही हूँ ना तुमको प्लस माइनस पूरा चाहिए सर्किट को ठीक है यू विल गेट just wait 1 second Nidhi can you come to my chamber you are having class now ठीक है okay after 12 o'clock you come okay now you can come I am in the machine lab electrical machine lab okay so here what we are doing actually we are connecting now look at the circuit I am showing you here you want to connect positive you want to connect negative so how will you connect it okay so for that with a single throw where positive will be there negative conductor will also be there so for that we are this is connected mechanically that means that switch we have to switch suppose you are using the switch in your home okay single switch you are now the single switch when you are connecting when you are turning it on you have a phase where you have a neutral where the current is flowing in the phase and it is coming out from the neutral yes or no that
yes,
means so the circuit is closed right in a single throw how the circuit is being closed understood or not
yes ma'am
like that got it who was asking
yes ma'am
okay fine any other doubt tell me you should know what is each and every function of the element okay when you are going from the doing the laboratory you should know what are the different components what is the use of the each component it's not that a voltmeter ammeter is there you take some reading do the calculation and over pictures voltage that a standard 6-7 student can do you are not here for that purpose you should know what is the theory behind it what are the different components you are using if you are seeing the video you would have come to the offline you should know each and every component how the ratings has been done what are the different components what is the function of each component how you are connecting everything you should be involved because now you have gone to a separate professional career engineering so you should be involved in the process involved in the experiment it's not that yes take the voltmeter reading ammeter reading voltmeter reading or do some plus minus operation with the help of scientific calculator verified Kirchhoff's voltage law no a big no for this you are not here for that purpose okay so be involved now a video will be shown to you you will then we will go for next another 2 circuit and we will verify it okay while seeing the video any doubt you tell madam will pause you and he or she will explain okay madam you can start Mona Lisa madam you will show na
Yes, madam.
okay
Now we will discuss about Kirchhoff's current law. In Kirchhoff's current law states that in any electrical network, the algebraic sum of current meeting at a point is 0. And this one is the this is our circuit diagram of KCL. It is same as to your KVL circuit, but in KVL circuit we use 3 voltmeter, but in KCL circuit we use 3 ammeter circuit. And previously it is regulated DC regulated power supply, and its rating is 0 to 30 volt and 3 ampere. Same rheostats are used here. This is 5 ampere and 50 ohm. Three same rheostats are using. This is second, and this one is your third rheostat. And this is one ammeter, 0 to 1, 0 to 0, 1, 2 ampere, and this is 0 to 0, 0 also 0, 1, 2 ampere, and this is also 0, 1, 2 ampere. In our circuit diagram, single phase AC supply is there, and this is my regulated power supply. This is output of the regulated power supply. This is my positive and this is my negative. First you connect all series connections, means positive to ammeter common, ammeter 1 ampere to rheostat first end, then second end to one rheostat, then second end of the rheostat to ammeter, then ammeter range point 1 ampere goes to negative. Then rest part of the circuit, this is same first rheostat second end to third rheostat first end, and third rheostat second end to ammeter common, the ammeter 1 ampere to negative. Our circuit diagram is over. Then come to our connection point. In DC regulated power supply, this is my positive, this is our positive, this is our negative. Positive to positive point to common of the ammeter, then 2 ampere to rheostat, first rheostat first end, and first rheostat second end to second rheostat first end, and second second end to second end of the rheostat to ammeter common. This is your second end of the rheostat, and this is the ammeter common point, and ammeter 1 ampere to our DC regulated power supply. Then first rheostat second end, second rheostat first end to third rheostat first end, and third rheostat second end to ammeter common, then third ammeter 1 ampere to then return of the DC regulated power supply. Our connection is over. Then our circuit connection is over. Then we switch on the MCB. Then switch on our AC supply to DC regulated power supply. Then take it at 0 position. Then switch on the power. Set the value at, in first ammeter we take 0 to 2 ampere. That's why we take 0 to 2 ampere, means upper scale. But in that ammeter 0 to 1 ampere scale we take lower scale. In that ammeter, also we take 0 to 1 ampere, then we take lower scale. Then we vary the regulated power supply. We take lower scale, that's why this is 1 ampere. Set at 1 ampere, sorry, 0.1 ampere. And second ammeter is approx 0.05, and this ammeter approx 0.04. Then we note down the reading. Apply voltage is 7.2 volt, and first ammeter is 0.1 ampere, second one is 0.05, third one is 0.04. First reading is over, then second reading. This is 0.2 upper scale. This one is 0.09, and this one is 0.08. Voltage is 14 volt, applied voltage is 14, I is 0.2, and second reading is over, then 0.25. Sorry, this one is 0.3 because we vary this and set it at 0.3 ampere. This is first ammeter. This one is 0.15. This one is 0.13. Total supply voltage is 23.3. Approx this is 23. 23.3, and this is 0.15, and this is 1.13. In that tabulation, in KCL circuit, I is equal to I1 plus I2. Means this I is equal to summation of I1 and I2. This is 0.1, this is 0.05, this is 0.04. Means 0.1 minus 0.09. This is 0.01. Means this 0.01 is error. In second table, 0.2 minus 0.17. This is 0.03. This 0.3 is error. So in third case, this is 0.02. This is error. Now KCL is verified. Now we shut down our supply. Take it at 0 position. Switch off AC supply. Then switch off the MCB. Thank you.
Any doubt in the video?
Ma'am, can you explain that remark part?
Yes, ma'am.
Ma'am, can you explain the remark?
Ma'am, how we will find error in that practical, ma'am?
Yes. I will share. Just wait.
verified. Now sort down.
See, what the error, that is the meter error. Okay, here is the meter is connected. The error is coming means total. What is the M? That is the main current is nearly that is equal to your summation of individual current. The summation is what? 0.05 plus 0.04. What is that? 0.09. Okay, but your main current is 0.1. That 0.01 difference is, that is the meter error.
Yes, ma'am.
Okay,
Yes, ma'am.
but in the virtual mode there is no error. Okay, but
Okay, ma'am.
in case this is the offline mode, that is the meter error. Okay,
Yes, ma'am.
understand? Okay, okay. Next, we are going to the KVL part.
Application of KCL and KVL. Now we will discuss KVL. KVL means Kirchhoff's voltage law. Kirchhoff, its objective is to find the voltage across branches. KVL states that the algebraic sum of the EMF and the voltage drop in a closed loop is zero. This is the formula: summation of E plus summation of IR equal to 0. This is the circuit diagram of KVL circuit, and this is my this is our AC supply, single phase 230 volt 50 hertz, and here we needed DC supply. That's why we take one DC regulated power supply, whose input is AC and output is DC, and its rating is 0 to 30 volt and 3 ampere. Across how many voltage it will come, that's why we take one voltmeter across that DC regulated power supply. Then we connect the circuit, first series connection. One ammeter, this is positive to common point, from one point to this is rheostat, and this is second rheostat, this is third rheostat. These three rheostats are in series. Then last rheostat end to negative. Then across each rheostat, one voltmeter is there. Suppose this is R1, then this voltmeter is V1. Suppose this is R2, this is V2, this is R3, this is V3. Means total voltage. This voltage V is equal to V. If total voltage V is equal to V1 plus V2 plus V3, means V is equal to V1 plus V2 plus V3. This then KVL is verified. This is our DC regulated power supply, whose rating is 30 volt and 3 ampere. This is the output, positive and negative. This one is our rheostat, whose R1, whose rating is 5 ampere and 50 ohm. Same three rheostats are there. This is first and this one is second. Same 5 ampere and 50 ohm. Then this one is a third. This is also 5 ampere and 50 ohm. Now we will go for connection. First, we will do the series connection. Output of the DC regulated power supply, this is positive and this is negative. This is so in DC regulated power supply, this is positive and this is negative. From positive to ammeter, common point. First we do series, that's why we will take ammeter 1 ampere. This is also 2 ampere, but we will take here 1 ampere. That's why we take the lower scale reading. Then this is the first end of my rheostat, 1 ampere to one fixed end of the rheostat. Then second end to third end of the rheostat. second rheostat first end, and second rheostat second end to third rheostat first end. Then third rheostat second end to the negative of the DC regulated power supply. Then series connection is over. Now we will go for parallel connection V1, V2 and V3. 1 voltmeter across first rheostat, second voltmeter across second rheostat, third voltmeter across third rheostat. This voltmeter connection is 0 to, this is 0 to 75. Same, this voltmeter also 0 to 75 connection. And third one is also 0 to 75 connection. Here in that scale, there is two scales, 0 to 150 and 0 to 75. We take lower scale, 0 to 75 scale, means we take lower scale reading. Similarly, this is 0 to 150 scale and 0 to 75. We take here say 0 to 75, that's why we take lower scale reading. Similarly, the first voltmeter also same range 0 to 75 and 0 to 150. We take 0 to 75 scale. This is common and this is 75. For that voltmeter, one display meter is there, digital meter. From there we can also measure the voltage reading of the supply voltage, or by one multimeter, by one multimeter also we can measure the DC voltage that is across these 2 points. Now our circuit connection is over. Now we will switch on the supply. First MCB on. Switch on the single phase AC supply 230 volt and 50 Hz. Then switch on the regulated power supply. And adjust it to adjust it to 15 volt. This is 15.1, approx 15 volt. Applied voltage is 15 volt. Then current flowing through that circuit is lower scale we have taken. That's why this is 0.1 ampere. This is fast voltmeter across fast rheostat. This is approx 4.5. Second one is 5. It mirror deflection is there. That's why you show 4.5, but it is 5. And this is also 5. First one, second one is 5, and third one is also 5. Then second reading we have to take, vary it and take it at 20 volt. Slowly we adjust it, and this is total 20 volt, means applied voltage is 20 volt. Then current flowing through that circuit is 0.13 ampere. This is 5.5 or 6. It may be 6. This is 7, I think 6.5 this one. This one is 7. This one is 6. This one is 7. Sorry, 6.5. And this one is 7. Then we will go for next reading. This is 25 volt. Slowly we will increase. Okay, approximately this is 25.1. We will take here 25. Current through that circuit is 0.16 ampere. And this one is 7.5 volt, fast voltmeter. Second is 8. Third one is 8.5. Our observation part is over. Now we will switch off the circuit. First, take it at 0 position and power off. Then switch off the AC supply. Then switch off the MCB. This is the procedure of the 2 off 1 experiment. Now we will go for calculation. According to KVL circuit, applied voltage is equal to V1, summation of V1, V2 and V3. Then in first observation, applied voltage is 15, summation of 4.5 plus 5 and 5. This is 14.5. 15 minus 14.5. This is 0.05 is your error. For second calculation, applied voltage, sorry, it is 0.5, not 0.05, it is 0.15 minus 14.5 is equal to 0.5. According to second observation, applied voltage is 20, summation of this 3 voltmeter is 19.5, error is also 0.5. And for third calculation, this is 20, applied voltage is 25, summation of 7.5, 8 and 8.5. 24. This is 1 volt. Means our KVL is verified. Thank you. Today we will discuss
Student, any doubt in the video?
No, ma'am.
Okay, all of you understand KCL and KBL?
Yes, ma'am.
So in virtual mode, we will verify. I'm just
Yes,
giving the reading. I'm sharing the reading. Just to take the screenshot.
Yes, ma'am. Wait.
ma'am, for KVL and KC.
Yes, just a minute. This one is KCL. Okay. KCL and this one is KBL. Has to take the KCL screenshot.
Yes, ma'am. Over.
KBL.
Ma'am, this is
Take
of
the
offline
screenshot.
mode or online mode? This is one of.
This is offline, na?
Okay.
The video what you show, it
Yes,
is
ma'am.
offline or online?
Ma'am, offline.
Offline.
So obviously the reading is for offline. Okay.
Ma'am, only one reading we have to take, no, ma'am. For KCL and
One
KVL.
reading means
Means that this one table, one observation table, no, for each for KCL and KVL.
this offline observation, no
Yeah,
need
yeah,
to write, just for reference we are giving.
Okay, ma'am.
Okay, just you keep it with you, and you tally it with the. You have to write in a rough record, na?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, that's the record you have to submit with offline and online reading both. But you have to mention this is offline reading for KCL and KBL, and online reading. After completing online experiment, you take the online reading.
Okay, ma'am.
Understand?
Yes, ma'am.
So no doubt. Then we'll go for the construction part.
Yes, ma'am.
Yes, ma'am.
My screen is visible. I
Yes,
think
ma'am.
all of
Yes,
you
ma'am.
have the link. All of you have the link.
Yes, ma'am.
Yes, ma'am.
Yes, sir.
Okay, so no need to give the link. Already Ohm's law you did. So the equipment required, tell me. For KCL first we will do KCL. For KCL, what are the equipment we
Ma'am,
need?
wires,
Switch, register.
battery, ammeter,
Ma'am, 3 ammeters.
resistor.
3 ammeters.
Yes,
Okay,
ma'am,
3
3
register.
registers.
Always
Yeah, ma'am.
with the battery, one
switch.
switch,
Ma'am,
connect
is
one
it
switch.
compulsory to take switch?
Yes, switch for safety purpose we are taking na, for offline
Yes, sir.
purpose.
Okay.
Also for online you take it, not taking. You are doing in online na. So register, then ammeter, three ammeter we need.
Yes, ma'am.
Then we are connect it like this so that the circuit is also good looking. Okay. So
Yes, ma'am.
everything is there or anything missing? Three register I am taking. You can also take the lamp law, light bulb it is written. You can also take the lamp instead of register. Okay, then 3 ammeter because we are taking the lamp load, also the register. So these are the load. Okay. Then next thing is your value.
Already all of you know na, this is for electron. If I click here, this is for conventional. Okay, then this is label, this is for value. After clicking, we get the value. Okay, so all the register are of same value, 10 ohm, 10 ohm, 10 ohm. Arbitrarily it is coming. You can change it. Already you know how to change. Suppose I am taking it arbitrary any value, 20, 30, 40, 20, 10, 10, no problem. You can change, or you can change the same value. Okay. Also, you take this is 20. You can take the same value or different value, no problem. Okay, then voltage 9 volt it is given. Take it 30, 40 or any value. Suppose 15 volt I am taking. Okay, then after this, what we have to do? Just close the switch. Okay, then you see, this is the flow of electron. This is the flow of electron. Now, if I click here, already you know, this is the circuit connection. According to our circuit, the resistor symbol, the supply, positive, negative. Okay, like this it is coming. Understand? So, you see, this is the flow of electron. Electron flow is, what is the direction of electron?
Opposite of current.
That is from which direction to which direction?
Positive to negative.
Positive to negative.
Electron flow is positive to negative.
Negative to
Negative to positive.
Yes, now it is the flow of what?
Current.
See,
Correct.
current direction is opposite of electron.
Yes, ma'am.
Okay. So this is like this, the circuit is there. Then click in this mode. Then you see what are the current value. First, this is the I current. To verify KCL, what we have to do? This is the junction point. Yes or no? From here the current is divided. This is the input current. You see, this current is input here, and here you notice how it will be divided. See this, it will be divided into this side and this side. Okay, so we have to prove I is equal to I1 plus I2. Yes or no?
Yes.
So here you see 0.5, here 0.25, 0.25. Summation is 0.5. Already ma'am has ma'am told that in the video there some error is there, but here no error is there because virtual mode we are doing, so no instrument error is there. Is it clear or any doubt?
yes, ma'am, clear.
Yes, ma'am.
I think no need to explain KBL. All of you do it because it is 3 register circuit according to your manual.
Ma'am, we can take 3
I'm audible?
voltmeter. Ma'am,
Voltmeter option is there. Listen. Here 1 voltmeter, 2 voltmeter is there. 2 voltmeter option. Okay. So
yes, ma'am.
take 2 voltage, then take another.
Ma'am, your
Can you
voice
do
is
KBL
lagging.
or
Ma'am, your voice is lagging.
Yes, ma'am.
Inaudible.
Ma'am,
okay, now I am audible.
understand. Wait. Anjana ma'am, voice is lagging, ma'am. So you have seen both, ma'am.
Now am I audible, student?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Hello? Okay, network issue is there. Listen, here 2 voltmeter option is there. Okay, so you have to connect 3 resistor in series. So 3 voltage you have to measure. So you first connect 2 voltmeter, then for another register across another register 1 voltmeter. Is it clear to all of you?
Yes, ma'am.
Yes,
ma'am. Yes, ma'am.
I'm not doing KVL because it is very easy. You can do it. Yes or no? Or I have to show it.
No, we can do it.
Can you please show once?
KVL, okay. Very easy. Just I'm taking 3 register connected in series. Same battery. I'm not connecting switch. Okay, directly I'm connecting. This is the circuit. If you connect switch also no problem. See, completed. Got it? Then you have to verify. In this circuit, suppose I will verify. How much voltage is there? I'm increasing the voltage little bit. Suppose 32. Then what you have to do? You have to measure the V1. How much it is coming?
10.67.
67.
Yes, ma'am.
Okay, you just remember it. This is how much?
10.67.
Also 10 point, because same resistance is there. You can take the different resistance value, no problem. 10, 20, 30, 10, 15, any value. No, this is not mandatory to take the same value. You can take the value. So all are 10.67. Then add it and tell me how much it is. 10.67 into 3.
Approx 32, ma'am.
Ma'am, 32.
Okay. Okay.
Yes, ma'am.
So verified. If you are using 2 voltmeter, you connect here. And after taking the reading, you can connect in the first one. Understand?
Yes, ma'am.
Or any doubt? Very simple experiment. Already theory. So KCL and KVL are verified. So just 5-10 minutes we are giving. After completing, Chitralekha madam.
Yes, madam.
Madam, they will go to their link now.
You have explained both Kirchhoff's current law and voltage law, na?
Yes, madam. Yes, madam.
Yes.
Any
Madam,
doubt? Any other doubt? Yes, madam.
Yes. Any doubt? Any doubt? Tell me.
No.
No, ma'am.
Okay. Just wait, madam. It is 12:05 now. Just wait. Another
Okay,
two
madam.
problems. Let me share this.
Okay, madam. I'm stop sharing. Okay, madam.
Yes. I will give you two problems. You solve this one by using Kirchhoff's current law and voltage law. Then you will the two experiment which you have shown offline, and those two circuits you will do, as well as this. My screen is visible to all of you.
Yes,
Yes, ma'am. Visible, ma'am.
Just yes, I am giving you a simple circuit. All of you have remembered the current divider rule? Yes or no?
Yes, ma'am. Yes, ma'am.
Just wait. Here I am showing you a circuit. You tell me, all of you draw this circuit. This one is 40 volt. This one is 10 volt. This one is 6 ohm, 5 ohm. This one is 9 ohm, 20 volt, 8 ohm, 5 ohm, 7 ohm. You will find out what is the voltage VCE. This one is A, B, C, D, E, F, G, H. You will find out what is the voltage VCE using Kirchhoff's voltage law, and VAG. VAG using Kirchhoff's voltage law, find out. Then we will do this circuit simulation in the simulation software. Find out using Kirchhoff's voltage law. One problem from Kirchhoff's voltage law, another problem for Kirchhoff's current law.
Ma'am, sorry, ma'am, I disconnect. Ma'am, can you please repeat, ma'am, what to find?
Yes, I have drawn just from this circuit, you find out what is the value of VCE, voltage VCE and VAG, you will find out.
VAG, okay.
Okay, voltage VCE means voltage of point C with respect to E. Voltage of point C with respect to E. Quickly do, because you have to do experiment in the simulation also. Similarly, VAG means voltage of point A with respect to G. You will find out. Do it quick, very easy problem I have given you, but a tricky. Theoretically find out, then we will do it in the virtual. Yes, anybody have found out? Anybody has done? Tell me yes or no. Let it be wrong. No issues with wrong. No problem if you are telling a wrong answer, no problem. Yes, tell me what is the value of VCE? Vivesh, are you doing?
Yes, ma'am.
Okay. Yes, so you will find out what, tell me? Voltage of point C with respect to E. So you start from E. I will start from point E and I will end to point, which point I want? C.
C.
Okay. I will start from E, I will end at C. I will see. Now, what is the current for, in order to find out the voltage across 5 ohm, I need
In
the
one
current in
circuit,
5
ma'am,
ohm.
1 ampere. In first circuit,
Here
1
it
ampere.
is, how much? 1
1
ampere.
ampere.
Very good. Very, very good. Then here this is how much? 40 divided by 7 plus 5 plus 8. 7 plus 5 plus 8 is 20.
2 ampere.
40 divided by 20 is how much?
2.
Okay. So VC will be equal to how much? VC will be equal to how much? Tell me. I will start from point E. Voltage of point C with respect to E. So I will start from point E and end it at C. So tell me what will be the equation. Here I am coming from E, current is flowing 2 ampere in the same direction. So what will be my equation? Tell me. Minus 5 into
minus
2,
5 into 2.
Yes, ma'am.
then
Yes, ma'am.
plus 10, then
Minus
Plus 5.
no,
Plus
ma'am.
Plus.
Plus, ma'am. Sorry.
plus how much?
Ma'am, 5 into 1.
5 into 1.
5 into 1.
Plus 5 into
1.
5 volt answer.
how much it is coming?
5 volt.
5 volt.
5 volt.
Okay.
Yes, ma'am.
Acha. Next VAG.
BAG is 1.
VAG, tell me. Yes. VAG, tell me. What is the equation? Tell.
Ma'am, minus 20 into 6.
I will start from G and it will end at
2 into
sorry,
7.
sorry,
2
ma'am.
into 7. 2 minus
7
2 into
into
7.
7 into how much? 2.
2.
2. Then
And again plus 10.
Plus 10.
Plus 10.
plus 10.
Minus.
Minus
Why minus?
Minus
Why
6
minus?
into 1.
Why minus?
Plus 6 into 1.
अरे क्या माइनस कहा कब माइनस नहीं तो प्लस प्लस नहीं तो माइनस क्या कर रहे हो
मैम एक
प्लस
बार मैम कंफ्यूजन हो गया मैम वो प्लस वाला मैम साइन कैसे
6 into 1.
1 yes मैम
how much it is coming
30.
16 plus 14
30.
ठीक है
yes
30
ma'am
volt. Yes, ma'am.
you will do this one this problem you will check it with the help of what simulation understood all of you
Yes, ma'am.
understood ma'am
हाँ
Yes,
जो
ma'am.
बना theoretically you have calculated you will check it in the lab second one question I am giving you because time is not there you have to do it in the online another simple question I am giving
Ma'am.
you हाँ बोलो
मैम एक डाउट था मैम मैम जो हम लोग जैसे वी सी का निकाल रहे हैं तो हम ई से सी क्यों जा रहे हैं मैम सी से क्यों नहीं जा रहे
voltage of C with respect to E
वो
voltage
वेक्टर
of
जैसा
point
वो मैथ
C I want voltage of point C with respect to E तो मुझे voltage at point C चाहिए with
Okay.
respect to E
यस मैम गॉट
समझ में आ
इट
रहा है
यस
तुम्हारा ये मतलब सपोज एक पोटेंशियल डिफरेंस है 5 वोल्ट implies what this is at 0 volt this is at 5 volt understood or not
यस मैम
with respect to this one this is at 5 volt understood or not
यस मैम गॉट इट मैम
so here yes second question I am giving you another easy question I was supposed to give one tricky question but I don't think I will get time I will do it in the theory class
Ma'am, will we write this ma'am equation on practical copy? Question.
yes
Okay.
practical जो कर रहे हो this one
Ma'am, we need to draw the circuit diagram also.
हाँ सर्किट डायग्राम करना और इक्वेशन लिखने जरूरत नहीं है सिर्फ स्क्रीनशॉट करके करो आई वांट यू टू डू
मैम सेकंड क्वेश्चन फॉर केसीएल
second question for KCL you will find out I have given 2 ohm all resistance are equal नहीं 2 अनइक्वल दूं इक्वल होगा तो पूरा एकदम इजी हो जाएगा this one you take it as 1 ohm this one you take it as 1 ohm 2 1 ohm 2 2 ohm solve karo what is the current flowing find out voltage you take I have not also calculated voltage simple I am giving you take 10 volt you will find out what is the current flowing okay here what is the current flowing here जल्दी
Ma'am,
करो
what is that last resistance 1 ohm
1 ohm ये वाला 1 ohm ये वाला 1 ohm 2 1 ohm 2 2 ohm इक्विवेलेंट रेजिस्टेंस कितना है मुझे बोलो what is R equivalent tell me
3 ohm
R equivalent is 3.
Ma'am, 1/3.
Yes,
1/3.
Ma'am, 1/3.
सही तो मुझे पता
3
नहीं.
ohm. Yes, ma'am. 3 ohm. 3 ohm.
1/3.
Ma'am, yes, ma'am.
1/3, ma'am.
1/3.
1/3. So what is the current here? Tell me. What is the current here?
Ma'am, 30.
30. Ma'am, R should be 3, I guess. 3 ohm.
अरे क्या तुम लोग ये कैलकुलेटर रखे हो, इतना कंफ्यूजन होकर के क्या आंसर बोल रहे हो, छोटा सा
ये
प्रॉब्लम.
कैसे होगा मैम? 1/3 होगा.
1/3 है ma'am. 1/3.
1/3 होगा.
1/3 तो करंट
Yes,
कितना
ma'am.
है?
Yes, ma'am.
Yes, ma'am. 30 हो जाएगा.
Yes,
Yes,
10.5.
30. All of you agree?
Yes, ma'am.
Yes,
मुझे
ma'am.
पता
30,
नहीं.
ma'am.
I don't know the answer. Neither
Ma'am,
I am
30
saying.
होगा. Sure.
Ma'am,
30
38.
होगा.
I'm confirm.
Yes, ma'am. 30 सही.
यहाँ पर देखो, इतना सारा 30 बोल रहे हो, गलत आएगा तो तुम सबको मार पड़ेगा. कैसे भी मारू ऑनलाइन में. लिखो देखो कितना कितना है, निकालो करंट. फाइंड आउट व्हाट इज द करंट. करंट डिवाइडर रूल लगाओ. कैलकुलेटर यूज करो, साइंटिफिक कैलकुलेटर यूज करो, जल्दी करोगे. 5 minutes you I will give.
मैम फिर से तो जो आप प्रीवियस क्वेश्चन दी थी वही बन जाएगा मैम, सर्किट डायग्राम.
Ma'am, 10, 5, 5, 10.
अरे तुम ये वाला बनाओ, कैसे हो. करंट डिवाइडर रूल लगाओ. व्हाट इज द करंट फ्लोइंग इन 1 ohm? व्हाट इज द करंट
10 ampere. 1
1 ohm में कितना है? 10. 10 एम्पियर. इधर 10 एम्पियर.
हाँ, 2 ohm में 5 ampere.
सही है तो.
Yes, ma'am.
Okay. You will check it. This one you will check it. These two problem you do it in addition to those two. बनाओ सर्किट बनाओ.
सिमुलेशन में मैम सर्किट बनाना है.
हाँ सिमुलेशन में बनाओ. अभी ये पहले दो फर्स्ट टू यू डू इट.
मैम, अभी जो आपने क्वेश्चन दिया दोनों का अभी बनाएंगे क्वेश्चन.
हाँ 4 सर्किट का सिमुलेशन बनाओ. आई विल आस्क यू टू शेयर द स्क्रीन. जल्दी जल्दी बनाओ. 40 minutes है. 15 minutes I am giving you to do the simulation. After that randomly I will call names. You will all of you will share screen. I have given the breakout room. You will share. अभी 15 minutes I am giving you. 12:35 you will start to sharing screen. Do it.
मैम
हाँ
मैम ये जो दो सर आप दिए अभी जो 2 क्वेश्चन मैम, उसे हम प्रैक्टिकल कॉपी में लिखे क्या?
हाँ तुम पहले क्या लिखोगे नहीं लिखोगे वो बाद में मैं बोलूंगी. अभी तुरंत करो. 15 मिनट्स के अंदर ये कंप्लीट करो सिमुलेशन. क्या लिखोगे नहीं लिखोगे दैट आई विल टेल यू लेटर ऑन. अभी 15 मिनट्स आई एम गिविंग यू. 12:35 यू विल स्टार्ट शेयरिंग. जल्दी करो.
I'm done.